Good afternoon, ladies and gentlemen of YouTube and Chucky2009, and tonight I'm going to be showing y'all a method for welding cast iron without a preheat. This is something taught to me by an old welder buddy, and I just figured I'd pass it along to y'all. So anyway, first off, a little basic crash course in metallurgy. As you probably know by the time you've gotten to the point of researching enough to find this video, that when you weld cast iron, it can't really take a large temperature shock. Like for instance, this little piece of steel square tube, if I wanted to weld this thing, I could go straight from room temperature, actually it's about 20 degrees out here right now, to as hot as it's going to get when I weld it and back, and just not worry about a preheat, just let it cool in the air. It'd be totally fine because it's steel and that's how it works. But the problem is cast iron is a little bit different. You can't really get away with doing that. Basically, it can't take a very large temperature shock. That's why you preheat it. You know, you take it from room temperature, slowly get it all nice and heated up, then weld it, and then slowly let it cool back down. You know, whether you stick it in some kind of oven, bury it in sand, you know, post-heat it with a torch and slowly back off the heat, whatever. You do everything within your power to keep it from experiencing a very large temperature shock. Now, there is a way to weld cast iron without that preheat, and that's what I'm going to be showing y'all tonight. Now, basically, this is what we're working on. This is an old International Harvester transmission casing, and it doesn't really have a crack, so we're just going to pretend it does and work with what I'm envisioning in my mind here. So this is our simulated crack, the soapstone line, and I just drilled a couple holes at the beginning and the end of the crack. And this is important because, you know, think of how a crack is going to travel through a piece of material as, you know, as it's full of water and it freezes and the water's expanding. You know, it's going to go straight through the material, and then when it gets to a hole drilled, it'll stop and just sort of disappear. So you have to drill holes at the beginning and ends of your crack, or ends plural if it's, you know, if it's one of those things that branches out. And you know, this will stop your crack from growing. You're going to have to drill as deep as the crack goes, and that's an important step. Now, the next thing we're going to be doing is being this out. Now, we're doing this because, as you know, you can't just weld over a crack. It'll come back in no time. So you have to grind the crack out of there. And again, we're going to have to go as deep as the crack is. Now, while we're doing this, I'm going to be using an angle grinder. You can use a die grinder if you're really patient or have a small crack, like one of those Dremel tools. Just whatever it takes to get this V'd out. Now, the reason I've held off on it is because we're also going to conduct a spark test simultaneously as we're grinding this out. And a spark test is, as most of y'all know, when you take a grinder to a piece of material, the sparks it gives off will tell you a lot about its composition. So we're going to find out if this is cast iron or if it's cast steel, and I'll show you what each of those looks like. You know, I'll give you a little crash course. So hopefully it'll be cast steel and you can stop screwing around and just weld it with a MIG like you would our nice little piece of our square tube here. So, alright, let's start grinding. Alright, ladies and gentlemen, so you now know what the sparks that come off this transmission casing look like, and so now I'm going to take the grinder to the table here, and if they match up, you're in luck, and you're working with cast steel, a lot easier to weld. All these problems with cast iron that we're talking about are not your problems, and but otherwise, we'll continue as we planned. Yeah, they're definitely a lot different, and that's because this is what appears to be gray cast iron. Now, I made an entire video on spark testing if that's something you want to learn about. And but anyway, this is definitely cast, and gray cast is not the hardest type of cast iron to weld, but it's also far from the easiest. It's not very forgiving, and it'll provide a good medium for me to demonstrate this for you guys with. So let's get set up and get ready to weld. Well, now it's time to explain this awesome top secret technique that we got going on here. Basically, if you put a large amount of heat into cast iron without slowly preheating it and then controlling the rate at which it cools, it cracks. So the trick is to, as simple as it sounds, just not put all that much heat into it. And how are we going to do that? We're just going to practice some basic heat input control techniques. I actually made a video about this too, if that's something else you want to learn about. But basically, the plan is that we are going to start from here, and then weld to the end of the crack, and then start from here, weld to the beginning of the first weld, start here, weld to the beginning of the weld we just did. This is what's known as backstepping your welds. And the reason we're doing this is because if you just start here and weld to here, as you go, the heat's just going to spread out and build and build and build. But if you do the backstepping technique, it only grows a little bit and then it stops. And what this does is it limits heat input. And in between each of these little welds, and when I say little welds, I mean like 1/2 inch or 3/4 of an inch, definitely not a full inch. These are definitely going to be some small welds. In between these welds, we're going to let the casting completely cool. Shouldn't take long because it's really freaking cold out here, but regardless, this is how we're going to control heat input and hopefully avoid any potential cracking issues. So let's get set up and then we'll start welding. One other thing, as soon as you get done with the weld, you're going to want to peen it immediately, which basically just, it's a scientific term for taking a slag chip and hammer and just beating the crap out of it. Or, if you want to go all high-tech redneck, you can buy a $20, air hammer from Lowe's. That's where I got mine. It works great for this. But anyway, the reason we're going to peen this weld is if you imagine your weld bead, and as it cools, it's being pulled in all directions, and if you hammer on it, you're going to push it out a little bit, and that's going to also work to relieve stress. So let's demonstrate and make our first weld. So it begins, YouTube. Alright, now as you can see, we do have a lack of fusion going on over here, so this would probably require a second pass and a little bit of touch up there. But that's our first weld. That is not a large weld whatsoever, and we're gonna wait and let it cool until you can run your fingers directly over the weld. And do this at your own risk. If you burn your hands off, not my problem. And that's cooling pretty quick because I just did this. But one other thing I'd like to add in is, this is probably not a good solution for any kind of cast iron repair you have, just, whatever random kinds you can come up with, because the weakest parts of a properly done weld are the beginning and the end, and when you do this, because you have a bunch of small welds, pretty much all you have is a beginning and an end and a beginning and the end. So, if it's an engine block or transmission casing or like a water pump housing, whatever, it's probably going to be okay. But if this is some kind of large load-bearing cast iron, structural support, probably not the best idea. So, yep, well. Yeah, okay, let's do another one. All right, ladies and gentlemen, let's come over here and have a look at the final outcome. As you can see, it's completely cool to the touch. And it's all in one piece. There's no cracking or nothing. We do have some little metal chips of nickel electrode and gray cast base metal everywhere. That air hammer kind of sends them flying a little bit. But just looking at this weld, it's definitely pretty well hammered into submission. It's a little bit on the concave side. It's a little bit low. I would probably want to give this thing another pass. But, realistically, that's a personal choice. I don't doubt this thing would hold gear oil. I'm just a little bit that way with my weld sometimes. But, as you can see, we did no preheat. We did no post-heat. And it worked. So this is hopefully a technique you can use. It'll help you. I mean, if I was repairing this for a customer or something, I'd put that extra pass on there, then grind it smooth and call it a day. It'll hopefully help you out, like I said. So anyway, I hope you all have enjoyed this video. I'd like to thank you all for watching, and don't forget to rate, comment, and subscribe for more. If you're interested in learning more about welding cast iron, I'll be posting a few more videos here in the very near future. So as always, thanks for watching. Have a nice night, everybody. Yeehaw.